Okay, I'll share my screen looking at 901, starting the new chapter. So in the last chapter, we were looking at trig. And in this new chapter, we're still looking at trig, but we're looking at trig functions. So we're looking specifically at sine, cos, and tan functions, what they look like, and how they travel around a unit circle, which is what we touched on very briefly last chapter. And then we're going to be introduced to the inverse trig functions, which are sec, cosec, and cot, or cotangent. So let's start. All right, so angles of any magnitude. So in chapter 4, which was the last chapter, we examined acute and obtuse angles by looking at angles turning around a unit circle. So when an angle is acute, we know it must be its acute version. But if we know an angle is an obtuse angle, it could be many a different depending on what our parameters are. So it could be different angles. We could have the acute option, we could have the obtuse option, we could have the reflex, the one bigger 180 and 360 option. So we can find angles of any size by continuing around this unit circle. So as you remember, or as you've probably seen in the past, a unit circle is essentially a circle with a radius of 1. So what I'm going to draw here, I'm going to split it into 4 parts. This is my unit circle. And my degrees in this first section here, or actually this is my 0 degree line, and quadrant 1 is anywhere from 0 up to 90 degrees. Quadrant 2 is anything from 90 up to 180 degrees. Quadrant 3, so let me put on, sorry, this is quadrant 1, quadrant 2, quadrant 3, so we're kind of going around anti-clockwise. Don't ask me why that's the case, because I actually would not know. So 22 to 70 degrees. And our last or fourth quadrant is anywhere from 270 back to 360 degrees. Okay, so we've got 4 quadrants, which means we could potentially have, I guess, well, you could have many angles, but you could have 4, let's think of it like 4 different angles. So we have to work out, given our sine, cos, and tan ratio. So as you know, sine theta equals y, that's just a fact. Cos theta equals x, and tan theta equals y divided by x. So we use those 3 facts and our unit circle essentially to determine what ratios are going to be positive or negative in what quadrant. So whilst our angle size stays the same, the fact whether it's positive or negative could change. So we're looking at the first quadrant. I would draw my triangle out like this. I know that my hypotenuse is 1. And let's just consider the bottom line as our x-axis, and the horizontal line x-axis, vertical line is our y-axis. So I come across x lengths, and x is a positive in this case, because if we're thinking of the middle being our 0 point, x would be positive, y would be positive. So from that, in the first quadrant, if sine theta equals y, we can see that y is positive in the first quadrant. So in the first quadrant, y is positive, sine is positive. If we look at cos theta equals our x value, we can see that in the first quadrant, x is positive. So sine is positive and cos is positive in the first. And tan being y over x, y and x are both positive, therefore we're going to get a positive result. So in the first quadrant, all 3 ratios, sine, cos, and tan, are all positive. So we use the acronym A for all. So let me I'll change color here. What's something that will stand out? Let's go green. So we use the acronym A in the first quadrant to say that sine, cos, and tan in the first quadrant would be positive. And I can do the same thing working around the unit circle. So let's have a look at the second quadrant. So if I drew my triangle in the second quadrant, change back to red here, I would have a triangle that hits and looks like this. Now, again, this would be 1 because that's my radius of the circle. Now, x starts at 0 and goes back negative. So really, x is a negative in the second quadrant, but y remains positive because we're above 0. So y is positive. So let's have a look at our 3 ratios again. Sine is y. Y is positive in this quadrant. So sine would be a positive result or give a positive result. Cos equals x. And as you can see, x is negative now. So in the second quadrant, cos would give a negative result. And tan is y on x. So we have a positive divided by a negative would give a negative result. So as you can see, the only ratio which is positive in the second quadrant is sine. And to remember that, we abbreviate, or we just use the letter S in the second quadrant to say that sine is the only positive ratio in the second quadrant. We can work our way through. I might not go over that, but in the third quadrant, I won't go over the 3 ratios in each, but in the third quadrant, cos is the only positive. So we use the letter or the acronym C. No, we don't, sorry. Tan is the only positive, all stations to central. So tan is the only positive, and in the fourth quadrant, cos is the only positive. So if you have a look at our acronyms here, we start with A in the first, S, T, C, and we use that acronym to remember what ratios are positive in what quadrants. So the way to remember it is all stations to central. That's probably the easiest one to explore. And the other bit of information that we should, or that we will be focusing on in this unit circle are our degree amounts. So we've got 0 degrees we started with, 180, and we're just going to look at the horizontal numbers. Now, degrees in this unit circle are always measured from the horizontal, meaning that in the first quadrant here, or if I put an A there, in the first quadrant, our degree amount is going to be 0 plus whatever our angle is, and I'm going to use theta. So 0 plus theta, meaning if my angle was, let's say 60 degrees, I would draw my triangle and my 60 degrees would fit in here, right? In the second quadrant, we always measure from the horizontal. So in the second quadrant, the angle that we would need to plug into our ratios would be our 180 take away whatever angle we're working with. So 180 take theta. So I start at the closest horizontal number, which was this point, take theta. Because if I had an angle of, let's say it was sine of 120 degrees, this was 120 degrees, well, I'd know that the angle on the inside of my triangle would be 180 take theta, or 180 take 120, which would give me my 60 degrees. So essentially, sine of 120 degrees is going to equal the same amount as sine of 60 degrees. So I won't go into too much detail now on the other ones, but measuring from the horizontal would mean that in quadrant 3, we would do 180 degrees plus theta. Will give us our angle here. And measuring from the horizontal, I could use, or I would use 0, but I can't because 360 is the maximum distance. So it's going to be 360 is my closest horizontal, take theta in this quadrant. So essentially those are the two concepts that you're required to remember in this, I guess, at the start of this exercise. So what I've got here is I've got a link to a HTML, which is going to let us explore the three ratios and see why we get this. So let's have a look. I'll try and bring that up now. I just have to swap my projection. Okay, so I'm not sure, or you guys should have seen the ratios sine, cos, and tan before. You probably wouldn't have known what they were or what they're used for. But let's whack our labels on and let's start with sine. As were in our unit circle, all stations to central tells us that A and S are the two quadrants which sine are positive. So if you have a look down, this is our sine graph here, and this is what it looks like. So as you can see, between 0 degrees and 180 degrees, sine is positive. So if I move my angle, as you can see, the angle over here is increasing. As I move the angle around the first and second quadrant, sine stays positive. To central, T and C. So tan and cos are the only positives down the bottom, meaning that sine throughout these angles or throughout this area of the unit circle is always going to be negative. And that, as you can see, it's reflected on the graph here. So between 180 and 360, sine is negative. And we can continue around for angles of any size for greater than 360, and essentially sine is just repeating itself over and over. So again, it remains positive. Angles between 360 and I think 540. And then between 540 and 720, it's negative, as you can see down the bottom. So let's reset that and let's look at cos. Now, cos, all stations to central, or ASTC, cos is positive in the first and fourth quadrants, and we'll see that happen as we move along the graph. So first quadrant, cos is above 0, it's positive in the first quadrant. It then becomes negative for the next two quadrants. And once we get around to 270 degrees, it becomes positive again, back to 360. And then again, same as sine, we could keep continuing for angles larger than, but no matter how large or how small the angle, if we're working within the first and fourth quadrants, cos is always positive. Let's have a look at tan. Now, tan is slightly different to the other two in the fact that it has asymptotes at 90 degrees and 270 degrees. So as you see, or ASTC would suggest that tan is positive in the first and the third quadrants. And we'll see that as we move around. So tan at the bottom here is positive, first quadrant. It then jumps to negative as we start at the bottom of the second line or after the asymptote. And that comes to positive in the third and negative in the fourth. Perfect. Same thing, we could look at radians and between 0 and 2 pi particularly. So let's have a look. Let's go radians, labels, same kind of thing, right? Sine, exactly the same, except instead of 180, we've got pi, because 1 pi radians are 180 degrees and 2 pi radians gives us our 360 degrees. So now we've got a bit of understanding of where that comes from. Let's jump back in to the last, or back to our Word document. Okay, so moving on, let's see how we can use this information from our unit circle to answer some questions. So again, this is just going over, or this is an excerpt from the textbook. It's just going over your all stations to central rule. Just saying that A means all ratios are positive, S sine is positive in the S quadrant, T tan is positive in the T, and C cos is positive. So all stations to central is how we remember that. And the other important information on there being our angles here. So in our first quadrant, we just take whatever our angle is. Second quadrant, we take our closest horizontal, which is 180, take our angle. Third quadrant is our 180 plus our angle. And fourth quadrant is 360 minus the angle. So it will be very useful in questions, and I still do this to this day, is at the top, you just whack your unit circle on and you put all stations to central, which will then also allow you to pop in your triangle wherever it is, pop your numbers on and work out, that's the wrong numbers, but yeah, work out what your ratios are. So let's have a look. Okay, question A, find all quadrants where sine is greater than 0. So sine is greater than 0 in A for all are positive. S stands for sine is positive, and the other two, sine is not positive, seeing as only tan and cos are positive. So part A would be quadrant 1 and quadrant 2, as you can see from our diagram there. Part 2, where is cos less than 0, or basically where is cos negative? Well, cos is negative wherever all and C are not, because in A and C, cos is positive. So cos must be negative in the other two quadrants, or quadrant 2 and 3. Okay, next question. Where is tan less than 0? Where is tan negative and cos positive? So tan is negative in C and S, but cos has to be positive, so we have to take the C only, because in S only sine is positive, but we need cos to be positive. So yeah, so tan is negative, cos is positive in quadrant 4. Okay, finding the exact value of tan 330 degrees. So what I would do there is I would draw my unit circle. I would know that 330 happens in this quadrant. Yep. So I know that if I put my A, all stations to central on, only cos is positive in this quadrant. So the fact that I'm in this quadrant and I'm finding tan, that tells me that tan will be negative. Tan is negative, and 330 degrees, well, I have to go back to my unit circle and I have to use this knowledge here. So to find the angle that's going to be on the inside of my triangle in here, I must do 360 take 330, which gives me the fact that this must be 30 degrees. Or tan of 330 is the same as negative tan of 30 degrees. Now that I know that, I need to find exact value. So I go back to my key triangles here, which are on your reference sheet, remember, and I'm going to equal negative is going to remain negative, and then I need to find what's the exact value of tan 30. So I'm looking at this angle here, and tan from that angle is TOA, so 1 on root 3. So it is negative 1 over root 3, and that will give me my answer. So that's the exact value of tan 330 degrees. Okay, so let's plug that in here, and then let's go on with the second question. So that would be negative 1 on root 3. Now looking at sine 225 degrees. Well, 225 degrees I know is going to happen in the third quadrant. So my line would be somewhere in this quadrant. So in this quadrant, I know that tan is the only positive, so I'm going to get a negative value. And I need to now look at my horizontal. So I'm taking the closest horizontal, which is 180. 180. I should put sine there first. So sine 180, and then in this quadrant it's 180 plus. So 180. Sorry. how much are we over 180? We're over 180 by 225, take 180 gives me 45. So therefore I get negative sine 45 degrees. Well, I take the sine of this angle, so SOH, so 1 on root 2. And I can fill that in over here. So 1 on root 2, negative 1 on root 2 will be my answer for this one. Okay, now I'm asked to simplify, or looking at part C, simplify cos, let's delete this, simplify cos 180 plus x. So cos 180 plus x. So looking at this 180 plus x would put me into this quadrant here. So seeing as tan is the only positive option, I know that I'm going to get a negative value. And my 180 plus x, well, I have to take whatever my x value is and plug that in here. So cos 180 plus x would be the same as negative cos of x. So whatever my value of x is over 180, which is what we saw in that last question, which was the 45 degrees. So I can plug my answer back into part C. So cos 180 plus x is the same as negative cos of x. Perfect. Part D, I'm given a ratio which is sine x equals negative 3/5, and I'm given a fact which is cos x is greater than 0. And then it's asking me to find the value of tan x. Okay, well, I've given two parts here that I can use. So sine is negative, produces a negative result. So straight away I know that it must be in the third or fourth quadrant. And I'm also given that cos is positive in this quadrant. So that would indicate that it's in quadrant 4. So I'm working in the fourth quadrant. So essentially I'm going to have, oops, that's the eraser. Essentially, I'm going to have my triangle happening in this quadrant here. My x value goes in here, and I know sine equals 3/5. So sine is O over h. So that tells me that my O value is 3 and my h value is 5. And to find the unknown side, which I'm going to need for tan being opposite and adjacent, I need to just use Pythagoras to find that. So I'm going to do 5 squared, take 3 squared, or c squared minus b squared gives a squared. So 5 squared, take 3 squared gives me 16. So root of 16 would be 4. So that would say that this side of the triangle is 4. Now I've got my 3 values on the sides of the triangle. I can find my tan of x ratio. So being in the fourth quadrant, I know that only cos is positive from my unit circle. So I'm going to get a negative result. So negative and tan of x, or negative tan of x, or tan is negative tan, what's tan over a, or basically negative, my opposite side is 3, so 3 over my adjacent side is 4. So negative 3/4 would be my answer for D. Okay, so a few things to remember there. We have firstly, what ratios are positive, and secondly, make sure you're always going from your closest horizontal. And you will get a lot of exact value questions, so ensure that you're using your exact value triangles on your reference sheet to help you work out your exact ratios or exact values. Perfect. So that's the first kind of questions explained. Now, looking at a case where our angle is greater than 360. So remember the name of this exercise is any magnitude, meaning that we could have angles greater than 360. And these are quite simple actually, because we just have to basically find out, well, how much greater than a full rotation is this angle, and then just apply our normal result or our normal method of solving. So 510 degrees, I'd go a full circle will give me 360. And I have to work out, well, how much more is 510? So that's pretty easy. 510 take away a full rotation, or 360, means that I've traveled an extra 150 degrees around after my first rotation. So really what I'm solving is cos of 150 degrees. Perfect. I can put brackets around there to make it look simpler. Okay, so what I do usually at the start of every question is I draw my unit circle. So this is my unit circle here. 150 degrees, I know happens somewhere in this quadrant. I put my all stations to central on, which tells me that sine is the only positive value in this quadrant. So if I put in my 150 degree angle, 150 degree angle is here, and I use my 180 take my 150 to give me the angle on the inside, which gives me 30 degrees. So 2 bits of information here. First one, sine's only positive, which would mean that our cos would be negative in this quadrant. And we need to find negative cos of 30 degrees. So I keep my negative sign and I replace cos of 30 degrees because I need my exact value. I use my triangles down here, meaning I'm taking the cos of this angle. A over h is √3 on 2. Negative √3 over 2 would be my answer. So angles larger than larger angles than a full rotation are quite easy. If you then had an angle that's larger than 720 or 2 full rotations, again, same thing. Just take off however many rotations and find your less than 360 degree value, or your value here like we did. Moving on. Now, negative angles. We could have negative angles. As you can see in our question here, we could have tan of negative 120 degrees. And these are quite simple again. The only difference being, instead of traveling around the unit circle, starting at 0 and going this way, we are now traveling in the opposite direction. So we start from the same point. We start at 0 being here, and we're traveling around in a clockwise direction this time. So 120 degrees would normally be, that's 90, about somewhere here. But because we're traveling in the negative direction, we're traveling around 90, and 120 would be down in our third quadrant. So let's solve over here. Drawing my unit circle as I always do, all stations to central. Now, the all stations to central doesn't change. So we're in this quadrant down here, meaning tan's the only positive, meaning because we're looking at tan, we're going to get a positive result. So I don't have to add my negative. But what I do have to do is I have to work out what my angle in here is. So this was 120. I'll do my 180, take my 120, which will give 60 degrees in here. So because it's positive, I'm going to leave it as a positive result. And tan of negative 120 is the same as tan of positive 60 degrees, which I then again use my exact value triangles. Tan of my 60 degrees, TOA, so opposite over adjacent, is √3 on 1, or the same as √3. And that will be the answer for that question there. So that's the end of explanation for this exercise. So there are two crucial points we touched on. If I scroll back up. So we touched on our ASTC rule, or all stations to central, to let us know whether our ratios will be positive or negative in each of the quadrants. And we also touched on the fact that we need to measure angles from our closest horizontal. So whether that's 0 degrees, 180 degrees, or 360. Yeah, good luck with this exercise. And I'll end the recording there.